Hello, welcome to another video. So in this video what I'm going to talk about are problem solving techniques, specifically for 1D kinematics, because you'll see the way that we tackle problems kind of changes throughout the semester. But the first couple, or at least the very first one, the very first tip I'm going to give you, never really changes. Um, but okay, so first of all, know, I mean, this isn't a tip, this is just know those 5 equations I gave you, okay? Know the 5 equations. But the very first technical tip is that you need to read and understand, this is the big one, understand the question, okay? So you need to read it in its entirety and then understand it. So with understanding it, sometimes comes drawing it. Now you'll notice I won't draw out every question. I usually only draw the complex questions. But you'll see, just to get you going, I do draw a few just so you know how to do it. But you should start drawing the problems, okay? That way you can visualize what's going on. Because if you take it step by step by step, it minimizes the error, okay? Number 2, and this is kind of exclusive, well, not exclusive to these problems, but it's really well known. You want to do what's known as identifying knowns and unknowns. And these are things that you know, i.e., the acceleration's 5 meters per second squared or something, right? Unknowns are things you don't. And these could be things you're trying to solve for, or things you need to know along the way to get the final solution. Okay, so knowns and unknowns, things you know, things you don't know. Sometimes these knowns, I'm just reading this, I really effed up how that looks. I'm just going to give up writing the word these. Sometimes these knowns and unknowns are explicit, as in they are written out, okay? So they're written for you to see, or they're implicit, which means it's defined by you or not exactly written, okay? So what I mean by this is you'll define something, okay, so maybe your initial position, you'll define that at 0, right? And so that value would then be 0. Or it can be something where it's not exactly written, like a car stopping. You know, a car stopping would mean that your final velocity is 0, right? So it doesn't straight up tell you. It's implicit, okay? So when doing this, this is what you write. You'll write knowns. And this is how I do it too. Knowns. Unknowns. Okay. And you'll write out, you'll write out positions. You write out the velocities. And then acceleration. There's another one. Time. Okay. And then any other thing that's known. I will say, and I typically go in that order too. Position, velocity, acceleration, time. Okay. The other thing that's a part of this that I really will say is This is where you define a coordinate system, okay? So if you are, what I mean by this is, if you're a ball and you're moving this way, if I set this right here, the ball's initial starting place at 0, right? Then that would mean x initial is 0. Whereas if I set it over here and it's at 5 already, then x initial would be 5, okay? I'll typically opt for this, okay? So that's, again, part of this implicit, defined by you, okay? And so when you do your knowns and unknowns, you set a coordinate system, and I'll show you how to do that, okay? Step 3 is going to be choose equations from list of 5 that link knowns and unknowns. For example, if, trying to think of a good one here, if I know the final, or if I don't know acceleration, if I don't know accel in time, I won't use, generally this equation, right? Which has both time and acceleration, okay? Sometimes you need to use, sometimes you need to use multiple equations. And these are typically the harder questions. So these are the harder questions. And these are the ones that people really struggle with, okay? But I'll walk you through a couple of them. Once you do that, once you've got your equations, you've got your knowns and unknowns, you've drawn the problem, you understand it, then you solve, okay? And then the last thing is, once you've solved it, you've got some numerical value, you can check solution. And there's a couple things. Does it make sense? Okay. Like, for example, is time negative, right? Like, if time were negative, that wouldn't make sense. But the main way I check solutions is I check units. Okay, so look at units. For example, time needs to be in seconds. Okay. Position, typically in meters. Velocity, whoa, what just happened there? It's crazy. Velocity, meters per second. Excel, meters per second squared. So if I don't have these units at the end, I know I messed up somewhere along the way. And that's another way to check. Okay? So again, just a quick summary. Number 1, understand. And again, that comes with drawing it a lot of the times. 2, knowns, unknowns, and you would make your coord system here, your coordinate system. If you don't make one, it's implied you're using the typical Cartesian system. Then you use equations. Number 4 is solve. And number 5 is you check. Okay. So you do this for each problem, and this will really help break down the problem and really take a load off your brain, okay, while you're trying to solve it, so you don't have to do everything yourself, everything inside. You can write it all down, you can visualize it, and it helps a lot. So that's it for this one, and I'll see you in the next one.